Here we are with the overview of Unit 7, themed on space and the universe. And before I get to the performance expectations, just want to say this unit is meant to be fun and inspire awe with students. So lots of great videos, beautiful pictures, lots of hooks for students to just really appreciate. All right, so this unit does develop, these collection of activities develop 3 performance expectations: universal gravity, orbits in our solar system, and the evidence for the Big Bang. Now, it is titled Unit 7, but really this is flexible. Those 3-day units, or sorry, the 3 2-day units can be spaced throughout the year. So if you have 2 days before winter break that you don't have something for, you don't want to start the next unit, try out Halley's Comet. We'll talk about the ideal placement for each of them as we take them on. So this first one is Halley's Comet, and that is getting at using the mathematical representations of Newton's law of gravitation and Coulomb's law to describe and predict gravitational electric forces between objects. All right, that's good stuff. And that can be done in 2 days. Ideally, that would come after Unit 4 when they've done forces. But again, if you got 2 days somewhere earlier in the fall, this is a great time to use this material. All right, so let's take a little bit of a dive here. And again, themed on Halley's Comet. So here's just the first photograph of Halley's Comet, its return journey in 1986, and then 2003 using Hubble. They got this. So pretty grainy, really noisy data, but you can kind of see Halley's Comet there. All right, so they data mine and ultimately find out the pattern with universal gravity, and that is inverse square. So when the distance doubles, gravity quarters. So that is both like quadratic, double, quadruple, but also like inversely proportional. So it's probably, titled inversely quadratic. And of course, there's some good explanations for why in the activity. But moving along, I also just want to point out that this activity and really the whole collection of activities is such a fertile ground for talking about the cross-cutting concepts. Literally all of them are in there, and it's just so good. But particularly want to call out scale, proportional, and quantity. Obviously, with the scale of the Earth system, solar system, space, even larger. Then also just another shout out to some applications and really cool interconnections that we have. Once you understand the pattern with gravity, NASA has a great video on how you can then, again, cross-cutting concepts, use those same things to start tracking water and ice. And it's just amazing how much information about climate and our Earth is affected by tracking water and ice. So really high interest, grab students. Moving along, we're looking at using mathematical or computational representations to predict the motion of orbiting objects in our solar system. So again, real optimal placement here is after Halley's Comet, but you might just want to start with this one for all sorts of reasons, especially if you just finished Unit 3 on energy. They're going to have that. So I want to take a dive into where you would see it. Oh, first though, I do want to just show this is an excellent demo, super fun in itself, easy to make, but also you can just buy it. And of course, that is in the teacher calendar. But just playing with this. So they play with it, but then of course we go into teacher desmos, and as we just discussed, really tracking energy. And they can see as an object falls towards the Earth, gets over to position B, you can see it's going to have a lot more kinetic energy. It's closer to the Earth, so a lot of that's gravitational potential has already been turned into it. Here, farther away. And of course, energy is conserved, and I'm not doing a good job of that, but probably there is a little better. All right, but just wanted to show that they're using energy bar charts, conservation of energy, really good stuff. So, of course, optimal placement is after Unit 3. And again, I'm in slides 9 and 10, so deep into the unit. Yeah, I have the slide here too. So the performance expectation really does call out Kepler's laws. Now, we really want students thinking energy. That is very powerful, and it emphasizes the cross-cutting concept, but Kepler's law is specifically called out in the performance expectations. So I want to let you know there's resources to also connect it to Kepler's laws. And we really use like graph literacy and diagrammatic understanding to get there. All right, to keep moving though, we have the evidence for the Big Bang. And the optimal placement here is after Unit 5, when they've dealt with the electromagnetic spectrum. Again, that's optimal placement. It is flexible enough. It's a little richer after Unit 5, but certainly it can be, it is flexible. All right, so this is a great unit. So this is stations. You know, we've had stations in units 4, 5, 6, 7. And again, each station, this one's 0, so everyone's doing it. And that is, what is our universe and what do we see happening in it? So multiple great videos. You know, that's just so great about space, is there's a lot of great videos, but then they're always going to annotate and draw and respond. Then super fun. Everyone's doing this. This is all together, station 0. That's setting up how to do stations. And this is just a great station. So we hang up and you can just suspend it from the ceiling, or even, as I'll say, put it out on the football field. So there's a little diagram about where to hang all of these little galaxy cards. And so you can see on the front, there's just a beautiful picture of the galaxy. And on the back, there's some critical information. Distance, they're going to physically measure the distance with, you know, meter sticks or tape measure, something like that. And then we give them the relative velocity here. And there's some visual images on the red shift of that. But they do actually measure the distance, and it's all done to scale. So of course they can fill this out and start to get some critical information to understanding our universe. All right, so moving along there, and then if you don't, for whatever reason, you can't go outside, of course it's fun to be on the outside on the football field, but if you need to set it up in your classroom, here's some measurements to get specific about how to set that up. All right, then just want to point out 10 different stations. They are high interest, fun. They got great videos. Students are drawing things. They're putting on spectral glasses and looking at different light sources. It is excellent. And of course, we also got the James Webb telescope in there, which is in the news all the time now. So that is great that that's launched and sending back pictures. Students know about it. And if they don't, we certainly want them to know about it. So it's a great activity. And then, you know, ultimately they are to construct an argument for the evidence of the Big Bang. And here's just, you know, another beautiful visual that students come to understand. So that is the overview of Unit 7.